Hello everyone. Today we are going to discuss solution and colligative properties, some numerical problems on this chapter. Let's start with this problem. The problem is given. The following solutions were prepared by dissolving 10 gram of glucose in 250 ml of water P1, 10 gram of urea in 250 ml of water P2, and 10 gram of sucrose in 250 ml of water P3. The right option for decreasing order of osmotic pressure of these solutions is. This question is given in NEET 2021. Now let's see the osmotic pressure equation. That is, P is equal to P is equal to I C R T, where I know I is Bantoff factor, C is molar concentration, R is solution constant, and T is absolute temperature. So here we have to find out at first that 10 gram glucose means 10 gram glucose in 250 ml. See one thing, all the solutions are given in 250 ml. So if we find out the number of moles here, so we can compare the osmotic pressure. You can write P is equal to I N by V RT. Now for all the solutions here, I, V, R and T all are constant because glucose, urea and sucrose all are non-electrolyte, that is I is equal to 1, and all of them having same volume, that is 250 ml, and all are at same temperature. So we can write that is P is directly proportional to the number of moles, that is N. So N of glucose, that is 10 gram of glucose divided by molecular weight of glucose. So 10 by 180. Now, number of moles of urea, that is 10 by molecular weight of urea, that is 10 by 60. Here, number of moles of sucrose, that is 10 divided by molecular weight of sucrose, is 10 by 342. So see here, N of urea is maximum, then N of glucose, and lastly N of sucrose, right? So we can write P2 greater than P1 greater than P3. So that is the correct option. That is option A. Next, come to the second one. Here, the question is given the correct option for the value of vapor pressure of a solution at 45 degrees centigrade with benzene to octane in molar ratio 3:2. So, vapor pressure of the solution is asked. Now, what do we know? We know vapor pressure P is equal to vapor pressure of benzene plus vapor pressure of octane, because the solution is benzene to octane. Now, vapor pressure of benzene, that is nothing but pure vapor pressure of benzene at 45 degrees centigrade into its mole fraction. Similarly, pure vapor pressure of octane into mole fraction of octane. So, vapor pressure of benzene is given 280, and the mole fraction of benzene will be 3x by 3x plus 2x, we can write, because their molar ratio is given 3:2. Similarly, 420 into 2x by 3x plus 2x. So by calculating, we will get 336 millimeter of each. So that is the option C. C is the correct. Okay. Now come to the next one. The freezing point depression constant of benzene is 5.12 Kelvin kg mole inverse. The freezing point depression for the solution of molality 0.078 molal containing a non-electrolyte solute in benzene is. Okay. So it is asked the freezing point depression of the solution of molality is given. Of non-electrolyte also say. So how can it be done? See, we know delta TF is equal to I into K into M. Now, since it is non-electrolyte, I is equal to 1 and Kf will be 5.12 Kelvin kg mole inverse into 0.078 molar. So the value will be, after calculation, we are getting 5.12 into 0.078, that is nothing but almost around 0.4. Okay. So that is option E. Option A is the correct answer. Okay. Next come to the theoretical question. The mixture that forms maximum boiling azeotrope. Now, maximum boiling azeotrope means it will have negative deviation, obviously, and negative deviation of Raoult's law, and that is applicable for water plus nitric acid. That is option 4. Water plus nitric acid will be the correct answer, because negative deviation of Raoult's law will be applicable here for the maximum boiling azeotrope. Now, what is azeotrope? You can find in the full video lecture of the theoretical part. Okay. Now come to the another one. For an ideal solution, correct option is. Now, ideal solution means which will follow Raoult's law. Now, for Raoult's law, delta V mixing will be 0 and delta H mixing will also have been 0, but delta Z mixing can may be 0, may not be 0, and delta S also same, may or may not be. So here only second is the correct answer. Delta H mixing is equal to 0 at constant temperature and pressure. Okay. Next, if molality of dilute solution is double the value of molar depression constant. Now, what do we know? We know delta TF is equal to KF into M. Now, this KF only depend upon the nature of the solvent, not at all on its concentration of the solute. So, if the solvent molecule have not been changed, so Kf value will also not be changed at a particular temperature. So, whatever the molality, it has been increased or decreased, the Kf value for a particular solvent at a particular temperature will always constant. That is, the correct option will be unchanged. Okay. Now, this is very interesting question. See, the freezing point of a diluted milk sample is found to be minus 0.2 degrees centigrade, while it should have been minus 0.5 degrees centigrade for pure milk. how much water has been added to pure milk to make the diluted sample? This is very, very interesting question. Let's see how can we deal it. At first, let pure milk contain X volume and in diluted milk Y volume of water has been added. Okay. So what can we write? Suppose 1 stands for pure milk, 2 stands for diluted. So we can write delta TF1 by delta TF2 is equal to nothing but KF M1 by KF M2, or we know delta TF1 is 0.5, delta TF2 0.2, and M1, that is the pure milk, X. Why have taken X? Because we have taken X as the molality divided by M2. Here water has been added, so X plus Y. Because the number of moles will remain same, only the volume will change. For pure milk also the number of moles is same. For the diluted milk also number of moles of milk is same. So they will cancel out, only we will take the volume, right? So or from this equation we are getting three x is equal to 2y from calculation. 3x is equal to 2y, or we can write x by y is equal to 2 by 3. That means 2 volume of milk with it 3 volume of water. 2 volume of milk plus 3 volume of water. That means which option is correct? That is option 3. Option C. B. 3 cups of water, 2 cups of pure milk. So B is the correct option. Okay. Now come to another one. What would be molality of 20% weight by weight aqueous solution of Ki? This is very interesting question and very easy too. How can it be done? Now weight by weight is given. That means 100 gram Ki solution contain 20 gram Ki. Now we can find out the number of moles of Ki or molarity of Ki. How? Mass of water (100 minus 20). That is 80 gram. And moles of Ki 20 by molecular weight of Ki, that is 20 by 166. So molality M will be equal to 20 by 166 divided by 80 by 1000. So by calculation we will get 1.51. That is option is the correct option. Okay. Now come to the another one. Nestler's reagent K2HgI4 is 40% ionized in aqueous solution. The value of its Van't-Hoff factor we have to find. Now 40% has been ionized. Now let's see if it will ionize completely. What will be the nature of the ionization? K2HgI4. From there we will get 2K plus HgI4 2 minus. So here total number of ions are 3. We can write N is equal to 2 plus 1, that is 3. Total number of ions is 3. Now it is given alpha D is 40%, that is 0.4. Okay. Now according to equation, alpha D is equal to I minus 1 by N minus 1. So, or we can write I is equal to alpha T into N minus 1 plus 1. So 0.4 into 3 minus 1 plus 1. That is 1. So I value is 1.8. That is option B is the correct one. Okay. Next one. For 1 molar aqueous solution of the following compounds, which one will show the highest freezing point? We know freezing point delta TF is equal to I into KF into M. Now here KF and M are same. So delta TF is directly proportional to I, and I means degree of ionization, or you can say within how many ions, how much ions are produced in the solution. That will define I. So among them, let's see their dissociation. CO H2O whole 6 Cl3. From there we will get CO H2O whole 6 3 plus 3 Cl minus. So here I value is maximum 4. or rather we can write not I value, it should be written value of n is good. Now come to the next one. CO H2O whole 5 Cl Cl2 dot H2. By its dissociation, what we will get? CO H2O whole 5 Cl 2 plus 2 Cl minus. Here n is equal to 3. Similarly, from the next one, we will get this kind of dissociation. That is n is equal to 2. And in the similar way, the last one will not dissociate at all. Non-electrolyte, so n is equal to 1 here. Now, the maximum number of ions for the first one, then it will decrease gradually. So, freezing point will be lowest for the last one, because for this delta TF is equal to only Kf into M. But for others, it will be less than, rather it will be greater than Kf into M. 2 times, 3 times, 4 times greater than Kf into M. So the highest freezing point will be applicable, highest freezing point that is applicable for whom delta TF is minimum. So the correct option will be option. Okay. Option 4 is the correct one. Now come to the last one. The freezing point of benzene decreases by 0.45 degrees centigrade when 0.2 gram of acetic acid is added to 20 gram of benzene. If acetic acid dissociates to form a dimer in benzene, percentage association of acetic acid in benzene will be is asked. Now, how can it be done? See, we know delta TF is equal to I into K into M. Now from it, we have to find out the value of I, or I is equal to delta TF by Kf into M. Delta TF is nothing but given 0.45 and Kf is 5.12 into the molality. Molality is how much? 0.2 by acetic acid, molecular weight is 60, divided by 20 gram of benzene, that is 20 by 1000. So you will get the value of I, that is nothing but 0.527. Now, what is the formula we know? We know formula alpha A is nothing but n into 1 minus I divided by n minus 1. Now, what is n? N is the number of ionization, number of association. So here dimer is there, so n will be 2. we will put the value 2 into 1 minus 0.527 divided by 2 minus. So by calculating, we will get the value. How much it is? Probably 94.26. That's okay. So those questions are very important, and different kinds of questions have been discussed here. So please go through it, and for other kind of queries, you can check the other video on solution and go through the notes supplied in the classes.